8. Hi students, Assalamu alaikum. Can you all hear me?
Yes.
Okay, so we'll start the class. So today is a free session, right? If you want, like you can share with your friends the link and you can ask them to join as well. Okay, then they will be benefited out of this free class because this is one of the important lesson of your syllabus, right? So we'll start. Children, if you all have anything to clarify with me, please send messages in the chat to the co-host. Right? Please don't send messages to the host because I will not be seeing when you send messages to the host. So please make sure that you are sending all the time. If you have any doubt or if you wanted to clarify something with me, send messages to the co-host. And I would really appreciate if you unmute and speak. Right? I want the interaction throughout the class. Okay, so now let's start, right? So we'll start the class. So today, children, we are starting the lesson changes of matter. Okay, we are starting the lesson changes in matter, right? So now, children, this is a chemistry lesson. So whenever I start a new lesson, I tell the importance of the lesson. So therefore, it is easy for you to understand on how to work on this lesson, right? That is how I do usually, right? So now let me tell you as well. Now when you take this lesson, this is a chemistry lesson. Right children, this is a chemistry lesson. If it is a chemistry lesson, there is nothing to memorize. Okay, remember one thing. When it is a chemistry lesson, there is nothing to memorize. You have to know that chemistry is made out of concepts. Chemistry is made out of concepts. So if you have concept, what you have to do? You have to understand them. Okay, you have to understand them. You are not going to memorize at any moment in the class. You are going to understand how the chemical reaction is working, how it is done. So when you understand the concept, you can apply in all the questions that you get regarding this lesson, then probably you will get the full marks. So that is the target. You are not going to memorize any of the part of this lesson, right? So let's start. Okay, children? The best way to learn chemistry, this is the best way. You have to understand the concept. You can't memorize, right? It is not biology to memorize. You can't do that work here. You have to understand. When you understand something, children, listen very carefully. Now you understand, okay, this is how it is happening. So whenever they ask you in any different ways, when you understand how it works, you can answer that question, right? So therefore make sure at any moment, all the time, you understand the concept when it is coming to chemistry. That is the best way to study, right? That is the best way to study. You don't think if you memorize certain parts you will get the full marks. No, in a way, if they don't ask in a method that you studied, you will not be able to answer the question. If they ask in another way, in an indirect way, you don't know how to answer. So it will lead you to a difficult moment. So therefore, don't do that. Don't memorize. Make sure you understand the concept and learn. Okay. Now, this lesson is about changes in matter. Right? This lesson is about changes in matter. Now, what is a matter, children? What is a matter? Can you tell me what do you mean by a matter? Anyone? Any idea?
Things that has mass and occupies space.
Very good. Whatever the thing that it has a mass and has and occupy space. So whatever the object that you take, if it is having a mass and it occupies space, that you call it as the matter. What is the opposite of this? The energy. So energy is the thing that does not have a mass and does not occupy space. Now here we are not going to talk about energy. We are going to talk about matter, right? So now when you take a matter, right? When you take a matter, there can be changes in two types. There can be changes in two types. Okay, there can be changes in two types. So what are those two types of changes? You have physical changes and chemical changes. You have physical changes and chemical changes. Now, what do you mean by physical changes? Now, when you take a matter, children, you know matter has three mediums or 3 physical states as solid, liquid, gas. So when you talk about physical changes, it can change it can convert this physical states, right? If an object is at solid, it can convert to liquid. If it is a liquid, it can convert to gas. So when this happens, when there is no new substance produced, that type of changes that you call it as the physical changes. Listen here. You have physical states of matter, right, as solid, liquid, gas, right? So physical changes means where it will convert, right? Where it can change the physical states, but it will not provide or it will not produce new substance. Now, when you take a candle, you are having a candle. Okay, this is a candle. You are burning it. Okay, you are burning the candle. You are lighting up. So what is going to happen? When you burn this, it will melt. When you burn the candle, what is going to happen? It is going to melt, right? So when it is melting, children, what is happening? The candle is in the form of a solid. Candle is a form of a solid. When it is melting, it is being converted to the state of liquid. Now, when this conversion is happening, is there any new product is being produced or any new substance is produced over here? No. So that you
No,
call it
teacher.
as the physical change. That you call it as the physical change. Where you are converting, where there is a change in the arrangement of the particles. You know that when you take the 3 mediums, when you take a solid medium, the particles are tightly packed. The particles are being tightly packed. When you take the liquid, it is loosely packed. And when you take the gas, it is freely packed. So when you can see the arrangement, okay, arrangement of the particles, because matter is made out of particles. Matter is made out of particles. So the arrangement of particles is being changed. When it is changes only, it is being converted from solid to liquid, liquid to gas, right? So that if the arrangement of the particles changes, when there is no new substance form, that you call it as a physical change. Understood? Understood, children? Clear? Anyone has a doubt? Children, you all have to talk to me. You all have to be interactive. When you be interactive only, you will learn. If you are not interactive, that is not going to work. You all have to talk to me. You all have to reply. So that is where the learning is going to be interesting. Okay, I want an interesting session with you all. Right? So I hope that you all will do that. Okay? Right. So let me explain once again. There, when you take matter, matter means what? The thing that has a mass and occupies space, right? Matter is made out of particles. Matter is made out of particles. When you take matter, there are 2 types of changes that can occur in matter. One is physical change and the other one is the chemical change. What is mean by physical change? When you know that matter has 3 states of matter. There are 3 states of matter. What are those? Solid, liquid, gas. This is solid, this is liquid, and this is gas, right? Now, when you look at the arrangement of the particles, when you look at the arrangement of particles, look here. Let me move the camera, then you can see. Right? So when state, okay, in the solid state, the particles are tightly packed, right? When you take the liquid, it is loosely packed, and when you take the gas, it is freely packed. Then you can see the different type of arrangement of particles. So when this change is made, when the particles, the arrangement of particles are changed or converted, and they don't produce new substance, that type of change you call it as physical changes. Understood?
Yes, teacher.
Okay, so that is about physical change, right? That is about physical change. Now let me give you some example. Wait a minute, I'll arrange the camera. Does it look straight? Okay. So example for physical change. Now when you have water, right? Imagine you have the ice cube, right? You are having the ice cube. Look here. You are having the ice cube. These are ice cube, right? So ice cube is the water in the form of solid, right? So when you supply heat to this ice cube, it will convert to water. It will convert to water. That is the liquid state of water, right? That is the liquid state of water. If you convert heat, if you supply heat to the liquid state of water, it will convert to water vapor. It will convert to water vapor. That is a gaseous state. Now what is happening? There is the solid state of water, right? There is the solid state of water. When you supply heat, it is converted to liquid. When you supply heat to the liquid, it is being converted to gas. So now when this process is happening, you can see the arrangement of particles have been changed. Arrangement of particles have been changed. But when this change is occurring, there is no new substance formed. Okay, there is no new substance are formed. So therefore, this type of change, you call it as physical change. This is one example for physical change. And melting of wax, or you can tell it as like when you crush a stone, right? You take a stone, right? This is a stone. You crush it. Then it will convert to powder. Then it will convert to powder. What is happening? The lump form is being converted to the powder form. So the physical state is different. Physical state between these two are different. So that type of change, you call it as physical changes. Clear?
Yes.
Okay,
Yes.
now let's talk about the chemical changes. Let's talk about the chemical changes. That is what you need for the lesson. Chemical changes are the thing that you need for the lesson of today. You are not going to talk further about the physical changes. That is just to give an introduction. There are two types of changes. We are not going to talk again about the physical changes. Okay, now when you talk about chemical changes, you are going to have some substances. Okay, you are going to have some substance. What are substances? Like particles or some other element. Okay, when these particles or substance, let me tell it as existing substance in other term. Okay, you are having some existing substance, the substance that you have. When this existing substance undergo a change, okay, when this existing substance undergo a change, and if they produce new substance, that type of change you call it as chemical changes. That type of change you call it as the chemical changes. What is that type, children? You are having some existing substance. When it undergo a change that produces new substance, you call that as chemical changes, right? That you call it as chemical changes. Once again, what do you mean by chemical changes? You are having some existing substance. If those existing substance undergo a change or a chemical reaction, if it produce new substances, you call it as the chemical changes, right? So whatever the substance that undergo a change, whatever the substance that is used to undergo a change, you call it as the reactants. Okay, whatever the substance that is used to undergo a change, you call it as the reactant. Whatever the new substance that is produced by the change, you call it as the product. You call it as the product. So this is the basic of the lesson. This is the basic of the lesson. Look here, children. Now you don't need much about the physical changes. That is to give an idea. Come here for the chemical changes. What do you mean by chemical changes? Understand. Right? Don't memorize. There is nothing to memorize over here. You just have to understand what are they trying to tell you. Okay. You are having some existing substance which you have in front of your eyes. Right? So if that substance undergo a change or a chemical reaction, and if they produce new substances, that type of change you call it as chemical reaction. So whatever the substance that you're using to undergo a change, you call it as the reactant. And whatever the substance, the new substance that you get out of the, but after undergoing the change, you call it as the product. Clear? Clear? Did you all understand what are they trying to tell you, children? Come on, children, you all have to talk to me. That is where you will learn.
Yes, teacher, I understood.
Okay, so that
Yes,
is
teacher.
the basic
Yes.
of the lesson. Right, that is the basic of the lesson. Okay, now when I give you a question, right, when I just give you an example, you are having magnesium. Okay, magnesium is reacting with oxygen gas. Okay, magnesium is reacting with oxygen gas, and they are producing magnesium oxide. And they are producing magnesium oxide. Now, can you tell me what are the reactants and what are the product? What is the reactant and what is the product?
Magnesium and oxygen is the reactant and magnesium oxide is the product.
Very good. So whatever, now you can see magnesium and oxygen that is existing, right? That is existing. You are using that in order to create a change. So that you call it as the reactant. You are using for the chemical reaction. After the chemical reaction, this arrow indicates after chemical reaction. After chemical reaction or after any type of a reaction, right? So after the reaction, there is a new substance produced. You don't find again magnesium and oxygen. You don't find something like this, no? Magnesium and oxygen gas, no. You don't find something like this. You find something new. So that is a new product. That is a new substance. That you call it as the product. That you call it as the product. Now, did you understand what is meant by a reactant and what is meant by a product?
Yes, teacher.
Okay, so that is the basic. That is what you have to understand throughout the lesson. Now, when you talk about chemical reaction, now first let's start with the chemical reaction. Now, children, in order to study this lesson, you have to know three main things. Okay, in order to study this lesson, you have to know three main things. Okay, if you don't know, you are going to memorize it now. Okay, the first thing is the periodic table. The first thing which you have to know is the periodic table. So, does everyone know the periodic table? Whoever is here, do you all know the periodic table, children?
Yes, teacher.
Right? So let's write it. Take out a book. I hope you all are having a book in hand
Yes.
of us in order to do questions and stuff like that. So you all have to practice now. Okay? Even though if you know the periodic table, that is not a problem. You are going to write it again. Okay? You are going to write it again. Okay? Draw the periodic table. Okay, what is the first element? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So these are the first 20 elements that is given into your syllabus to memorize. You have to memorize, okay? Children, and again, when you get a paper, right? This is a tip, okay? When you are attempting a paper or you get your school term paper, anything, okay? When you know that, okay, chemistry questions are going to be there in the paper, take out a rough paper, right? Take out the rough paper and draw the periodic table in that. Draw the periodic table in that. That will save a lot of time in your exam. Trust my words. It is going to save a lot of time in your paper. You don't have to draw each and every question like if you get MCQ, you don't draw it in a side. No. Take a rough paper, draw it neatly where you can refer whenever you do a question. Right? So when you do like that, you will save a lot of time while you're answering the paper. So that is a tip. right? So how many groups do you have in the periodic table, children?
8.
How many groups? Very good. You have 8 groups. 1, 2, 3, 4, 5, 6, 7, and then 8. How many periods do you have in the periodic table?
4.
4. 1, 2, 3, 4. Right? So then you have to know the valency. Then you have to know the valency. So the valency charge varies how, children? The first group. The group 1 has what type of charge?
1.
Plus 1. You have to mention the sign. Plus 1, plus 2, plus 3, plus 4, or minus 4, and minus 3, minus 2, minus 1, 0. These charges are must. Whenever you draw the periodic table, you have to draw with the charges. You have make sure you write the elements, you name the groups, you name the period number, and you name the valency of the group. So this is the complete periodic table that you have to study. If you don't know, children, please study now. Repeat 3 to 4 times, you will automatically learn it. Okay, you will learn it. Right? Now study, children. This is for your own good. Don't take like, okay, I'll study tomorrow. You will not study. You will keep for another day. That happens. Right? So here, you are here to learn. Right? You are going to spend 2 hours. So you are going to learn and finish it off. You don't have to give it tomorrow, for tomorrow. Right? Study now and finish it. Right? I'm giving you time in between to study, understand, everything can be done. Okay, do it, children. Do that work. Do that work. If anyone who don't know the periodic table, don't feel shame. You're the one who is going to do your paper. No one else is going to come and do. Right? So make sure you study this now. This is for your own good. Right? Trust my words. This will help you. And you need this to know when you're learning in the class even. Now, like for upcoming minutes, you will know the importance of this. Right. And then, children, you have to know the polyatomic ions. You have to know the polyatomic ions and their charges. You have to know the polyatomic ion and their charges. Right. So, according to the analysis, there are around 6 main polyatomic ions. Okay, there are around 6 main polyatomic ions. They probably, even though the textbook has given you like around 15, you don't have to memorize all those. Like there are few sets. If you memorize that, that is the only one they repeatedly ask question. So therefore, you don't have to worry. If you memorize those 6, that is more than enough. But you have to memorize with the charge. Okay. Yeah, sure. I'll give you some tips for O level. Why not? Like, you know, in between, I'll give you. Right now, let's study first. Like while I'm giving you a work to do, at that time I'll tell you what to do. Okay? Right. Now look here. The first polyatomic ion that you have to know is hydroxide. Okay, the first one you can remember as hydroxide. Right? Hydroxide has the formula OH minus. Okay, the formula for hydroxide is OH minus. Then you have to talk about nitrate. Then you have nitrate. Nitrate has a formula of NO3 minus. Right? NO3 minus. Then you have to talk about ammonia. Okay, you have to remember ammonia. That is NH4 plus. That is NH4 plus. Then you have carbonate. Then you have carbonate. Carbonate is CO3 2 minus. You have to remember this minus value. Those are the valency. Okay, those are the valency of the element. These are polyatomic ions. Right? You have to remember the valency of them. Okay. Then you have sulfate. Then you have sulfate. Sulfate is SO4 2 minus. Then you have phosphate. Then you have the last as the phosphate. Phosphate is PO4 3 minus. Right? So these are the 6 main polyatomic ions that you have to remember. Children, be honest yourself. If you don't know this, I'll just give you 1 minute. Please memorize it because you will need it in the upcoming part. Okay, trust my words. I'm not gonna lie. right? Trust me, it is important. So if you are a theory student, you will understand. If it is important, definitely I will force you to do that. Force you to understand and make you memorize in the class itself. If it is not important, I'm not going to force you and I'm not going to like scare you. This is important, saying a lie. No, that's not going to happen. That's a policy. That's not going to happen. But if it is important, definitely I'll make you to study. Right? Trust my words, children. This is for your own good. Trust me and memorize this now itself. Write it down if you want. Everyone write it, that's better. Even though you know this, the 6 important polyatomic ion doesn't matter, write this down. Okay, write it. I'll just give you 1 or 2 minutes, then we can move to the next part. And children, for today's class, you should be well prepared with the papers and pen to write and do attempt question and everything. Okay, be ready for that. We will be talking about the chemical reactions in a while. So for that, you need to write, you need to practice, you have to attempt. Everything should be done. Memorize, memorize, don't just stay. I want you all to work. Utilize this 2 hours and study now itself. Very good, Hannah. Hannah is done memorizing. Sulfate is SO4 2 minus. During physical changes, it cannot be like directly converted to solid to a gas, right? Anyways, it will be undergoing, right? Anyways, it will be undergoing like from solid to liquid, liquid to gas. Okay, it can't directly change from solid to gas. Okay, it cannot be done. Phosphate PO4 3 minus. Can't you see that? I'll show it. Wait, I'll write it big. PO4 3 minus. So this is the order. This minus and plus values are there. Those are the valency. Now for calcium you have plus 2. So similarly for this you have this value. You have to remember when you are making the chemical formula. Because when you are creating a chemical formula, you use the valency. Right? You need the valency to make the chemical formula. I'll teach you in a while. Is everybody's done? I want everyone to work. Children, listen to me. These are important one. And please don't send messages to the host. Okay, children, because I will not be seeing. So please send it to the co-host. Okay. So I hope you all have memorized. I believe in you all. Can I trust you all, children? Can I trust you all that you all have done the work?
Yes, teacher.
Yes, that's
Yes, teacher.
very good. I'm really happy about it. Good, good. So utilize the time. It really matters. You are spending 2 hours. Just don't waste it. You have to memorize and listen what I am saying. It is definitely going to be important. If it is not, if you are a theory student, you will understand. If it is not, I'm not going to force you. But if it is important, I will drag you through that. Okay? That's a policy of my teaching. Right. So then let's move. Right? This is very important, children. I hope that you all have memorized. I'm trusting you all. Don't break my trust. Right. Then the third one, the very important one for this lesson. Right? So whenever you are going to do a chemistry question, make sure you write all these 3 in the rough paper. That is the reactivity series. That is the reactivity series or the activity series. Both gives the same meaning. Right? This one is very important for today's class. Look here, children. So the reactivity series starts from potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, platinum, gold. Right? So this is the reactivity series. This is the reactivity series. Right, children? Now, what is meant by this reactivity series and why do they have arranged in this manner? Because, children, this is being arranged according to their reactivity. This is being arranged according to the reactivity of the element. Okay, according to the reactivity of the element. Which means the element above in the periodic table are highly reactive. Okay, the element above in the reactivity series are highly reactive. The element below in the reactivity series are low in reactivity. Now, when you take potassium and when you take copper, which is more reactive, children? Which is above in the reactivity series?
Potassium.
Potassium. So therefore, you can easily understand when you study the reactivity series, which is more reactive, like which when you analyze, okay, now you know the reactivity series, you identify the position of potassium and copper, right? Which is above, potassium is above. So therefore, you can easily come up with the idea, potassium is highly reactive, right? Potassium is highly reactive. And the element above in the reactivity series does not exist as an element. Okay, does not exist as an element. They always exist as a compound. They always will exist as a compound. Why is that, children? You know that the elements above in the reactivity series are highly reactive. So when they are highly reactive, they start to make bonds with each and every other elements. So therefore, they are always found in the form of a compound. Right? For an example, when you take sodium, you can't find sodium atom in nature. They are always found as a compound, as sodium chloride, which you use the common salt at home. So that is sodium chloride, right? So you can't find sodium in nature. You find sodium chloride. From that, you extract the element and you take them. From that, you extract the element and take them. So similarly, when you take magnesium, magnesium is also like that. Magnesium chloride. So this you might have learned in Unit 3 of grade 10. Structure of matter. In that lesson, you might have learned. So these are compounds. Compounds are made out of ions. Compounds are made out of positive and negative ion. They will have a positive ion and a negative ion. Right? With that combination only, this compound is formed. Right? So element below they exist as an agent. Now when you take, this is the last one, which is gold. So you find gold as an element. Right? You find gold as an element. Gold is not extracted from another element or another compound. No, you can find gold as one single element. So that is gold. So let me write the names. Memorize it. This is platinum. This is silver. Mercury. I want everyone to memorize. Copper. This is hydrogen. H is hydrogen. This is lead. Okay. Then this is tin, iron, zinc. So above that, you know, right? Aluminium, magnesium, calcium, sodium, potassium. You know them, right? So to find highly reactive, the elements above in the reactivity series are highly reactive. Elements below, they are low reactive. So that is why gold's color does not change. Now gold, when you buy a gold jewelry, they do not change their color. Forever, they are going to be in the same color. Right? Forever, they are going to exist in the same color. They don't change. But when you seen silver? Silver, after some time, it will fade. It will cause rusting or the color will change. So, or any other metals, like when you take iron, right? When you have an iron nail, after some time, it will cause rusting. It will cause rusting. So, rusting means, children, where the iron is have interacted with oxygen in the nature. Now, when you keep an iron nail on a table for so long, After some times, you will see that, okay, the color of the iron nail will be changed. A rusting will be coated onto that. Why is that? Because of the oxygen in the atmosphere has been reacted with the iron. So when you take gold in the other hand, when you even keep it on the table for years, that will not change in color. That's not going to change in color. So that means gold is having a low reactivity, while iron is having, comparatively, iron is having a high reactive. So therefore, they will react with other elements in the nature and they will bring a change into their color or into their physical state. Not physical state in the sense they are not going to change into liquid or something, but there are changes that can be made. Study this, children. Everyone should study the order, right? I will be asking. I'm not a strict teacher, but if the work should be done, you have to do it, right? Because you are here to learn. Make sure you utilize that. The grade 10 class happen usually at this time. I'm starting a new lesson. That's why I thought of giving this as a free seminar, a free session. Same time at Fridays at 7 to 9 p.m. Yes, yes, Sahara. Whatever it is below, it is low reactive. Yeah, above in the reactivity series are highly reactive. That is why sodium you can find above, right? So therefore, you can't find sodium as an element in the nature. You always find that as a compound, which is sodium chloride. So that is the common salt. So you don't find sodium in nature. From this sodium chloride, you extract the sodium, okay, from this compound. That you will learn in grade 11 electrochemistry lesson, the down cell. You will study in that. So that is what I was telling you. This lesson is important. That is the main reason why I wanted to teach this as a free seminar, because children, this lesson is the foundation for your grade 11 chemistry, right? This is the main foundation for your grade 11 chemistry. So make sure you utilize it. Aluminium will change because they are above. They can react. Okay, imagine if the iron is itself changing the color, why don't aluminium change? Because they are above iron. So therefore, obviously, it can change. Right. Have you all memorized this, children? I want each and everyone to memorize. Okay, I'm giving you time to do that. Yeah, I think there is a song to memorize this order, but I don't know that. I have heard, like, when I was studying, like, my friends were telling, but I don't seriously remember now. Does anyone know the song? Like, there is, I don't remember actually, but there is a song to remember, but I don't remember that. What is that? Basically, I did not study in that method. I just memorized it. I even did not take time to memorize. Eventually, by doing questions, I started to study this. Like, automatically, I learned. Do you know that, Amina? Do you know the song? No. Okay. So even I don't know. If I know that, inshallah, I'll share it in the group. Above sodium and below sodium, this one, Zahra, you're talking about. That is, I took as an example. Sodium, you can't find it as an element, you find it as a compound. That's just an idea. But this arrow indicates that the element above is highly reactive. The element below is low reactive. In order to show that. Okay, you know I'll sing another song. That's nice. Do you memorize in that way? Ah, here I got the song. Please stop calling me a zebra. Instead try to learn how copper, mercury, save platinum, gold. So is that the one you're talking about? So how it is related to the order? Please stop calling me a zebra. Okay, zebra is for zinc. Instead try to learn how copper, mercury, save platinum, gold. It's really new. Ah. So, but I don't understand how it works. Instead is for iron. Okay. Then try to learn. Please stop calling me. What is that stands for? Please, you don't have anything starting from P, no, here. Calling. K. Okay, potassium. Me. What's that, child? It's really confusing. Okay. All right. But in a way, if you remember in that way, that is going to be nice. But in a case, don't get confused. Okay, don't get confuse yourself. But better just you repeat it 3 to 4 times this order. That's enough. You don't have. That's not a big deal actually, right? Okay, children, have you all memorized? Done. Okay, the order of the song. That's good. You are interested to search and do something, right? Nice, nice. Keep it up. So in a way, if you memorize it in that way, that's okay, no problem. But at the end of the day, you should be memorized with this. That's it. No any other condition. Okay. All right. I hope that you all have memorized it. Okay. Can I trust you all? Repeat it once again. So if you like to check, open your mouth and talk. Right. So start from potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, platinum, gold. Did you all understand? Did you all memorize it, children? I want everyone to do that. Yes?
Yes, teacher.
Yes, teacher.
Very good. So I hope that you all have memorized and let's start doing some questions, right? So the people who don't have the tute, but I think the theory class student will have it, the printed ones, but the free seminar student who don't have the tute, can you all raise your hand and I can send it to you? Right. So can you please start doing these questions, children? Do from question number 1. Give me a minute. Okay, start from question number 1 and do until and do until question number 7. Right? Start from question number 1 and do until question number 7. I'll send you the answer, like the tute now. Give me a minute. I'll send it. What's happening? Right. So children, can you all please leave a message to this number, or I'll send it to the group. Are you all there in the main group? So I'll send
Yes,
it.
teacher.
So I'll send it now,
Please
right?
first the name
So if you
of the
all are
group.
there, if you all are not there, you are not there in that group. Okay. So I'll send it now. If you receive it, put your hands down, and the people who are not in the group, keep your hands raised. I'll send it personally. Later, I'll send you the link to the group. Then you will get the updates regarding the free seminars and everything, like daily questions and stuffs like that. I'll send it to the group. The people who don't have it, they can get it. Right. Okay. Children, I have sent it now. Children who don't receive it, if you all did not receive it, can you all please send a message to this number? I'll send it. I'll write it on the board. This is my number. Don't send it to the admin's number. Send messages to the admin. Okay. He will wonder. Right. So I'll write my number on the board. So please send message to this as asking for the tute. I'll send it. Right. This is my. If you all got the tute from through the WhatsApp group, put your hands down. Right? Send a message to this number, not any other numbers. Then I'll send it. Others, please start doing the questions. The theory class students also do it. I hope you all are having the tute in hand. Do it. If anyone did not receive the tute, like from the group, send a message to this number. I'll send you the group. I'll send it to you through WhatsApp.
Yes, can you resend the tute in the group?
Yeah, I'll send it. Give me a minute. Okay, I have sent it. I have resent it to the group. So this is a tute for the whole lesson, but we are not going to complete the entire lesson today. Right? Right? I have sent to the people who have asked me. Okay. So now I hope everybody is having the tute. Okay, I'll add your number once the class is over. Can I know your name, please? Send your name as well. Then I can add you, like I can save your contact and I can add you. Okay. Okay, Hazura, I'll add you once the class is over. Now start doing, everyone. I want everyone to work. Children, when you start working only, you will understand your ups and downs. So whenever you don't attempt it, you feel that, okay, in a way that like, okay, I understood. But when you attempt a question, you will not be able to do it. Why is that? Because you have not practiced yourself to do the work, right? So make sure you work. That is why I'm telling you to do the work. So that is where you will understand your ups and downs. Now maybe you don't you don't know a definition for a specific thing, you don't have the proper, you don't remember, maybe you studied with me but you don't remember at a point. So in order to overcome that and avoid the like mistakes that you have made, that is why the questions are given to do. So understand that and everyone has to attempt it. Hannah, did you get the tute or you want me to send it? You have raised your hand. Hayafaz, did you receive the tute, child? Or you want me to send? Okay. Do it, do it. Everyone has to do the work. This is not a physical class to check your work, but do it. I trust you. Yeah, the grade 11 class is happening on tomorrow, on Saturdays at 4 p.m. to 6 p.m. Yeah, we do past paper class, which is happening on Wednesdays from 6 p.m. to 9 p.m. 3 hours class. So we have started the grade 11 past paper. Grade 10 is done. Yeah, sure, you can join, dear. You can join. Once the class is over, contact me. I'll let you know the details. Everyone has to work. I trust you that you work, right? Next, we have to study an important part, right? About chemical reactions. So when you understand that only, you will be able to face, according to me, you will be stable with chemistry when you understand how to do that, right? But mainly they ask that type of a question about the chemical reaction, chemical equation, balanced one. And today, inshallah, I will be teaching you about it. So we'll study that. Do it, do it. Don't just wait. Somehow, once the class is over, I'll add you. Okay? Hiya, do you want me to resend it to the group? Hiya, can you send a message to my number, dear? Then I'll send it to you personally. So other children will wonder why she's there. I'll send the number in the chat. Okay, I have sent my number message. I'll send it. Finishing time, it is at 9. Just 2 hours. So probably, inshallah, you will be having the maximum knowledge from this seminar, inshallah. And children, once the class is over, if possible, drop me a feedback of the like if there are any changes or if you are satisfied with the class, anything you can share. Once the class is over, send it to my number. When you attempt only, you will understand your mistakes. So do it. Then only you will recall what you learned for 1 hour with me when you attempt it alone. Right, children, can we discuss? Don't do the 7th one. Children, wait. I by mistakenly given you to do the 7th question. Don't do the 7th. Do until 6. Not 6 actually. Why I have given that? Do until do until 5. Once you all are done until 5, we'll discuss. Please don't do until 7 because I did not have teach you all this part. I have by mistakenly given you. I'm sorry for that. Do until the 5th one. Very good. Amina is done. And who else is done? Safia is done. We'll see who else is have done the work. Good job, children. So it's good to be active. I want that to happen.
I'm done,
Very
teacher.
good, Yasmin.
I'm also done, teacher.
Sorry.
I'm done, teacher, with my work.
Very good. Okay, let's wait until others do. Sahna has done. Very good. Right. I think the time is enough, no, children. We'll discuss. All are just for an understanding, right? So they don't actually give you such a way to answer. This is not what you get in your exam. Don't blindly believe to get to get the definition to answer. No, you don't get such thing. This is just for your understanding. Okay, it's purely to develop the idea of what you learned for 1 hour with me, right? For that purpose only I have given that questions, right? So what is your answer for the first question? The first question says that what is known as physical changes? You know that. What do you mean by physical change? What is mean by that? Anyone who is willing to tell? Be volunteer and have confidence to answer. Anyone?
Change of physical state of a substance without creating a new substance.
Very good. That's simple and sweet. That's enough, right? Then what is known as chemical properties? Sorry, not chemical properties, chemical changes.
Change of physical state of a substance with creating a new substance.
Physical state? No. Not related to physical state. Where you have existing substance, when the existing substance undergo a change and if they produce new substance, that you call it as the chemical changes. It is not related to physical state, right? You have the existing substance. If the existing substance undergo a change and if they produce new substance, that you call it as the chemical changes. Okay? Right. Give two examples for physical changes and chemical changes. Physical changes like melting of candle, like crushing a stone. Those two are examples. Or evaporation of water. That could be also an example. For chemical changes like burning firewood. Okay, when you burn firewood, formation of ash, it will convert to ash and it will liberate new gases. Then you can tell rusting of iron, formation of rust, that is a new substance. So those two will be enough, right? So then what is the term given to the substance take place in a chemical reaction? Okay,
Reactant.
that means the existing substance. What is that?
Reactant.
Very good, that is reactant.
Reactant.
The new substance produced during the chemical reaction is known as what?
Product.
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 Very good job. So that's all that you have to try for now. Right. Now let's get into the main part of the lesson. Right. Let's get into the main part of the lesson where you have to learn. Okay. What do you want me to type, Safia? Did you get the answers or do you want me to type it? Okay. Look here, children. Look here. Stop all your works. Right. What do you want me to type? Chemical changes. Okay, I'll write it on the board. Okay. When the existing substance undergo it's like slanted. Existing substance undergo a change and forming new substance is known as chemical changes. Okay, this you call it as a chemical change, right? Can I erase it? Okay. So now children, we are going to study about the chemical reaction, right? We are going to study about chemical reaction. You are welcome. Okay. So now we are going to talk about chemical reaction. Children, listen to me very carefully. So as you know, from the beginning I was telling, if it is important, what will I do? I'll make you study. Okay. If it is important, trust me, I'll make you study. Okay. Chemical reaction, right? We are going to study in detail about chemical reaction. Okay, look here children. Now when you talk about chemical reaction, what is meant by a chemical reaction? Where you have the reactants. Okay, chemical reaction means where you have the reactant. Reactants are the existing substance. When they undergo a change and they produce new product, that process you call it as chemical reaction, right? You have the reactants which you call it as what? You call it as the existing substance. When they undergo a change and if they produce new substance, that you call it as the product. Okay. Now when you talk about chemical reactions, there are 4 types of chemical reaction. Okay, there are 4 types of chemical reaction. The first type of chemical reaction, you call it as the combination reaction. You call it as the combination reaction. Listen very carefully. These are very important, children. Concentrate well. Okay, you call it as the combination reaction. Then the second one, this is the first one. The second one is the decomposition reaction. Okay, that is decomposition reaction. And you have the single displacement reaction. Single displacement reaction. And as the fourth one, you have the double displacement reaction. Double displacement reaction. Right? So these are the 4 types of chemical reaction, and today I will be teaching you all 4 types of chemical reaction. Right? Now let's first of all talk about combination reaction. Right? So now with the word combination, you can understand, okay, there are 2 different reactants where they combine and form a product. Right? Imagine you have A substance, B substance. After chemical reaction, you form a product. Okay? You have a substance, you have another substance, you combine these 2 and form a new product. That idea is only the combination reaction. Now you have magnesium. Magnesium is one substance. Oxygen gas is another substance. When you join these 2, you will get magnesium oxide. Now, how do you get that? Is the chemical formula. What is the valency of magnesium, children? Come on, now you have to know that. Plus 2. What is the valency on oxygen?
-2.
Minus 2. What do you have to do next? You have to erase the sign in front and interchange the value. Then when you interchange, you will get magnesium 2, oxygen 2. If you have same number, you can cancel them off. You don't have to write them. At the end of the day, you will get magnesium oxide. This is what you got. Understood how it is happening? This you have to learn in Unit 3 of grade 8.
Yes, teacher.
Okay, this is chemical reaction. Right? Another one, another example. You have sodium plus oxygen gas. What is the valency of sodium?
+1.
Plus 1. What is the
Plus
valency
1.
on oxygen?
-2.
Minus 2. What do you do next? You erase the sign. Then what do? You
Interchange.
cross multiply. Then what is going to form? You will get sodium.
Na2.
Sodium will get the valency of oxygen. Oxygen will get the valency of sodium. Then Na2O1. Do you write 1 in common when you have a chemical reaction? No.
No, teacher.
Generally, you don't do that. Then you will get Na2O. This is a chemical reaction or the chemical formula. This process, you call it as the chemical formula. Right? So, that type of chemical reaction, you call it as combination reaction, where you have 2 reactants, combining those 2, it will form a new product. That type of reaction, you call it as combination reaction. Understood? Right. Look here.
Yes,
I'll
teacher.
explain it once again. Right? Since some of the students did not understand. Look. Right? You have 2 substances. Right? Substance you don't tell in chemistry. When it is related to a chemical reaction, you don't use the word substance. You use the word as reactants. Okay? Now you all are big enough to use the word reactant. You are matured to use the word reactant. Right? Now A and B are reactants. A and B are reactants. When these 2 react together, it is going to form a new product. It is going to form a new substance. Do you use the word new substance? No. You are big. You are not going to use the word new substance. You use the word as product. Okay? You use the word reactant and product. That type of reaction, you call it as combination reaction. You combine the reactants and it will form a new product. That type of reaction, you call it as combination reaction. Look at the example. You have magnesium. Magnesium is going to react with oxygen. Right? Magnesium is going to react with oxygen. Magnesium is one reactant. Magnesium is a reactant. Oxygen is also another reactant. Now what is going to happen in this combination reaction? Both of them will react. Combine. Right? Then how do you do the combination? By taking their valency. That is the chemical formula. The valency of magnesium is +2. The valency of oxygen is -2. You erase the sign in front. You interchange. Then they will be getting Mg2 O2. You don't write. If they are same numbers, you don't write. You cancel them. Then at the end, you will get MgO. Understood? Did you all understand?
Yes, teacher.
Okay. Very good. Okay. That type of reaction. What is this type of reaction, children? What do you call it as?
Combination reaction.
Very good. You call it as the combination reaction. Okay. Now, do you find it like easy to understand? It is flowing. The method should flow into your brain. After every type of a reaction, every type of a chemical reaction that you learn, the process should flow into your brain. So that is the perfection. That is the perfection. That is what I needed in the class. Okay. That is what I want you all to do it in the class. Right? So at the end of the day, all four type of chemical reaction, which is the most important part, should flow in your brain. Clear? So that is why I'm telling you to give your 100% of your attention. I need that. Right? So let me tell it easily and finish it off. Right. So the next type of reaction. Look here, now we are going to talk about the next type of reaction. We are going to talk about next type of reaction. So the next
Miss, how
type
to
of
balance?
reaction. Sorry, did you have any doubt?
Yeah, Miss, how to balance this?
I'll teach you the balancing part. First, understand how the reaction is happening. I'll teach you how to balance it, okay? Right. Now, chemical decomposition reaction. You're going to talk about decomposition. What is meant by decomposition? You decompose something. Any idea?
Making complex substances simple substance.
Yeah, something similarly, you break something into segments, right? As a simple idea, that is what you told was related to biology. This is chemistry, right? You have to think as a chemist, right? Decomposition means a process of separating. You're going to separate, you're going to divide, or you're going to break down. In that sort of a case, right? When you have one reactant, okay? When you have one reactant, it will break into two or more product. It will break to two or more product, as calcium carbonate will break down into calcium oxide and carbon dioxide. Did you see here? This is one reactant, just a single reactant. But what is happening? It is breaking down. It is breaking down. Breaking down into how many products? Breaking down into two products. That type of a reaction, you call it as the decomposition reaction. If it is decomposition, remember breaking down. You have one product, you have one reactant, they are breaking down into two or more products. Okay. Now, in other terms, this is one example. The other example, this is, and then remember, children, this is one of the famous equation, right? This is one of the important equation where you can see when you have tried a past paper, you will understand this one is being a major part. You, when it is related to chemistry, you get questions related to this equation. So study the formula. What is the formula? Calcium carbonate will break down into calcium oxide and carbon dioxide. If you want, I'll write it. Okay, you have calcium carbonate. It will break down into calcium oxide and carbon dioxide. Right? If you want, write the wordings as well. Okay, that will give you a better idea. Okay, children? Okay. Right? So the next example that I can give you is one of the most important one. I'll just give you three main important things. Okay, three main important decomposition reaction. This is a what? Key tip for the O level as well. Okay, not only for the grade 10 students, it is an advanced one for grade 11 as well. If you are a grade 11 student, this is more important. If you are a grade 10 student, you don't have to worry now itself, because anyways, If you are a theory student, you will learn it in the grade level. No worries. Like in a paper class and stuff like that. Right? But better to write this. Okay? The next one is where you have the potassium permanganate. Where you have the potassium permanganate. Right? Potassium permanganate is a type of a compound that will break down into potassium manganate. It will break down into potassium manganate. Right? And potassium manganate, manganese, I think I should write it smaller. Wait, I'll write it smaller. Another space won't be enough. Potassium permanganate. Right, you have potassium permanganate. It will break down into potassium manganate and it will break down into manganese. Okay, it will break down into manganese dioxide and oxygen. Right, and oxygen. This is one of the important. Why is it important, children? In order to produce oxygen, in the laboratory, they use this potassium permanganate. I'll write the names. Potassium permanganate. Right, and this is potassium manganese. This is manganese dioxide. These are important, children. You write it down. This is oxygen, as you know, right? So write this down if you want it. Anyways, I will give you to write this, but better to do it. These are, children, to be honest, you don't have to know, you don't have to show the reaction like which I did for magnesium and oxygen. That format does not needed to do this for chemical decomposition. When you remember the order, that is enough. When you remember potassium, calcium carbonate breaks down into calcium oxide, carbon dioxide. That is enough. They are not going to ask you to show the step of finding the reaction. No, they don't do that. So you don't have to do that. Memorize this. Take some time. Children, you have plenty of time at this age. You can just take few minutes and memorize this. Some parts you need to understand and memorize. Okay? Memorize it. Memorize the two equation first of all. Tell 3 to 4 times. Write it on a paper. You will easily understand. Calcium carbonate will break down into calcium oxide and carbon dioxide. Okay. Potassium permanganate will break down into potassium manganese, manganese dioxide, and oxygen gas. That's it. Nothing hard. Right? Then let's move to the third one. Third decomposition reaction that you have to remember. That is hydrogen peroxide. This is hydrogen peroxide, H2O2. Right? H2O2, which is hydrogen peroxide, will break down into H2O and oxygen gas. H2O and oxygen gas. Right? Now let me give you the balanced one. Let me teach you how to balance. Right? Children, balancing is a process where you equalize the left hand side elements and the right hand side elements. Now, you consider the arrow as the equal sign. Whatever before the arrow, the number of elements or atoms you have it should be equal to the number of the atoms or elements in the other side. This is the left hand side, this is the right hand side. So whatever the elements that you find in the left hand side, the numbers should be equal to the right hand side. That process you call it as the balancing. That process you call it as the balancing. Now for example, when I give you, let me erase this part. Right? You have sodium and oxygen. So when you break this down, sodium has +1, oxygen has -2. You erase the sign, you interchange, then you will get Na2, sodium to oxygen. This is what you will get, right? We did the example, right? Now, what I mean is, this is the left hand side. This is the equal mark. And this is the right hand side. Look here very carefully. Balancing is very important. When they are asking, listen children, when they are asking for an equation, chemical equation, if you don't write the balance equation, they will cut your marks. Right? They will cut your marks. They will deduct your marks. So remember to balance the equation and write. In order to balance, you have to understand. You can't memorize all the equation in the book. Some you can, but not all. So understand here. Look here. So in the right hand side, in the left hand side, how many oxygens do you have?
2.
So how many oxygen do you have here?
1.
1. So which means this inside, like on the left hand side, you have 2. Then in the right hand side, you have 1. So then you can convert the 1 in the right hand side as 2. Right? You can convert the 1 in the right hand side as 2. Right? How do you do that? How do you do that? You multiply by 2. So can you add? Now, in case I'm asking you, can you add something like this? Can you add the 2, like 2 oxygens? Is it correct or wrong? What do you think?
Wrong.
Wrong.
Why is that, children? In middle of a compound. Now, this is a compound. In middle of a compound, you can't add numbers. In middle of a compound, you can't add numbers. Now, here you have water. Can I write it as this? 4 oxygen. No, this is completely wrong. This doesn't make sense. Right? That is wrong. You can't add. Then where can you add? In front of the compound. At here. This is the correct way. Where do you add? Then it means that this 2 is common for this sodium as well as the oxygen. Right? 2 is common for sodium as well as to the oxygen. Then do you have 2 oxygens in this side? Do you have 2 oxygens in this side? You multiply. 2 into 1 oxygen gives you 2 oxygen. Then oxygens are balanced. Oxygens are balanced. Right? Then how many sodium do you have it in this side? 2 here and 2 here. 2 into 2, how many sodiums?
4.
You have 4 sodium. Which means in the right hand side, if you have 4 sodium atom, on the left hand side also you need 4 sodium atom. On the left hand side also you need 4 sodium atom. What do you do? What do you want to do? You have to make this sodium as 4. Simply you add 4 in front. Simply you add 4 in front. So did you understand how to balance? We'll do more question. Did you get an idea of how to do this?
Yes, teacher.
Yes, teacher.
Can you explain it again, teacher?
Yeah, sure. I'll explain it. First of all, tell me, did you all memorize this part? The 3 decomposition reaction, calcium carbonate and potassium permanganate, and for the hydrogen peroxide. First do that because I'll explain you the balancing part. I thought of doing together, but you all find difficult. That's okay. I'll teach it again. This is hydrogen peroxide. Memorize it. Don't write it in the tune for the theory class student. Don't do it now. I'll give you time to do it. Memorize it first of all. Understand the reaction between this. This is water and oxygen. Memorize this. Study this. Hydrogen peroxide. These 3 are very important. That is why I'm giving you. Right? So combination reaction is very easy. You can easily understand where you have 2 reactants. If they produce one product, that is a combination reaction. Soon, children, if you are done, let me know in the chat. I'll explain it, Rukeya. I'll explain the balancing part. Memorize. This is important. If I'm saying that is important, that is important. If it is not, I'm not going to force you. Right? I'm not going to force you. But in other case, if it is important, definitely I will force you. You know why is that? On a day you will thank me later. Because this is important. You need this for the exam. That is why I'm emphasizing this so much. If not, I won't do that. Right. Are you all done? Okay, Zahara is done. Who else is done? Let me know, children. I want everyone to memorize whoever is here. Okay? This is for your own good. If it is a theory class student, next class I will ask all the reactions. If it is a theory class student, next week I will ask all the reactions. So memorize it. Very good, Hajara.
Done, teacher.
Very good. Okay. So let's move. Now you have written this. I'll erase it in order to explain you the balancing part. Then let's move to the single displacement and double displacement. Right. Look here, children. Now I'm going to show you in detail how to balance. Balancing an equation. Okay. Look here. Now let me take an equation. What is an equation? What I wrote with an arrow head, that is an equation. Let's take sodium plus oxygen. Sodium is going to react with oxygen. Right. Now tell me the chemical formula. Now you are going to talk to me. You will learn about the chemical reaction, chemical formula. Now tell me what I am supposed to do to get the
Sodium
final
to
product.
oxygen.
Sorry, come again.
Sodium to oxygen.
Okay, how did you get that? What's the process behind that? Tell it again, then you will understand better.
Take the valency.
Okay, to take the valency. What is the valency of sodium?
1.
+1. You have to mention, is it plus or minus? If not, your entire answer is going to be wrong. Okay, right. Then, what is the valency on oxygen?
-2.
-2.
-2. Okay. Then what do you do next? You erase the sign in front. Then what do? You interchange the value. Then you will get
Interchange.
Na2O. This is what you will get as the product. Now, what I mean as balance, this is the left hand side. Now, this is like the equal sign. When you do an equation like in max, right? You always check, okay, when you do, okay, from the left hand side, it should be balanced to the right hand side. Same concept it is going to play here, right? So this is the left hand side. This is the right hand side, right? The arrow is the equal mark. Remember as that. Arrow is the equal mark, right? Now, whatever the number of elements you have it in the left hand side should be equal to the right hand side. Clear? Got that idea?
Yes, teacher.
Now you check each and every number from left hand side. Is it equal to the right hand side? Now check oxygen. You have oxygen here as 2. Okay, you have 2. How many oxygens do you have here?
1.
1.
Then how can you make them equal?
Put 2 in front of Na2O.
Yeah, simply you have to multiply this one oxygen by 2 in order to make them equal. Right? You have to multiply the oxygen by 2 to bring them equal, to equalize. So, you add. Now, you can't add 2 as you tell. Right? You can't add 2 over here. 2 oxygen. This shows it is 2, but it is technically wrong. If it is a compound, you have to add before the compound. You can't add in between the compound. That is wrong. Right? You can't do that such work. Right? Then you add 2 in front of the compound. You add 2 in front of the compound. Then can you tell here this 2 is going to be common for the sodium as well as the oxygen. To sodium and oxygen. Why you have written it in the beginning? So which means it is common for both. Right? So 2 into oxygen 1 will give you what? What could be the answer? 2 into oxygen. What is that? 2. That is 2. You see here oxygen is 1. You multiply 2 into 1 will give you 2. Which means on this side now you have 2. 2 oxygen. On this side you have 2. Then both of them are balanced. Both of them are balanced. Did you understand that? Did you understand that? Okay. Now come to the sodium. Now you have balanced the oxygen on both the sides. Now that is done. Then you have another element which is sodium. How many sodium atoms do you have in the right hand side, children? 2 into 2. 2 into 2. What's the value?
4.
4. On this side, how many sodium do you have?
1.
You have 1. Then how do you make it as 4?
Multiply by 4.
Very good. You multiply by 4. When you multiply by 4, you add 4 here. So therefore, they are balanced. Understood? We'll do more questions. For now, did you understand? Oh, sorry.
Yes, teacher.
So another question. Another one. Right? Now you have, let's take as calcium and oxygen gas. Calcium and oxygen gas. Right? So when you have calcium and oxygen, what is the valency of calcium?
+2.
You have +2. What is the valency of oxygen?
-2.
-2. Then what do? You erase the sign in front. You don't need that. You don't need it anymore. Then you interchange. You cross multiply. Then you will get calcium 2 O2. Same numbers do you mention?
No.
Children, now the question that I'm asking in order to teach you, okay? You tell yes, no, is it okay to add or no? You answer, you should answer me, okay? So you can't add that. That is technically wrong. Then this is going to be the formula. Now children, you have to balance. Now you have to balance. How do you balance? From the left hand side should be equal to the right hand side. That is the rule that you have to follow. Now, how many oxygens do you have in the left-hand side?
2.
Then, how many oxygens do you have it in the right-hand side?
1.
1. Then, how do you make this as 2? How do you equalize?
Multiply by 2.
You multiply by 2. Where do you add 2?
The front.
In the front of the compound. You add it here. Okay. Now, you see on both the side, oxygen is balanced. Now, you come to calcium. How many calcium do you have it in the right-hand side?
2.
You have 2. How many calcium do you have here?
1.
1. How do you make it 2?
Multiply by 2.
Multiply by 2. Where do you add number 2?
Front.
In the front of calcium. Now this is balance. This is the balanced equation. Right? You erase all the working. Right? This is the balanced one. This is what you have to write. Understood?
Yes, teacher.
Right. Now it's your turn. Right? Now it's your turn. You have aluminium reacting with oxygen gas. I'll give you 1 minute. Do the working. 8:45 I'll ask the work. Now it is 8:44. 8:45 I'll discuss. Soon try it. Follow the same steps. You don't have to worry then. Let's see whether did you understand the concept now. Okay? Let's see whether you understood the concept or not. Yeah, next week we will be continuing this lesson, but it's not going to be a free session. That is the regular theory class. So if you want, you can join the class by doing the payment. Okay, I think the time is enough. Did you all do it? Write the steps, attempt the question. Theory class students, you can write it in the space which I have provided for the additional note. You can do at that part. Others can, the paper or the book that you are doing the work, you can write it on that. Okay, look here children, we'll discuss from here. Look now don't do. Okay, now stop your work. Right? Now don't attempt. Now look how it is done. Right? Okay. Now children, now first of all you have to make the chemical formula. What is the valency of aluminium?
+3.
What is the valency of oxygen?
-2.
Right? Then you erase the sign. You don't need them. Then what do? You cross multiply. So aluminium will get 2 and oxygen will get 3. Okay, aluminium will get 2 and oxygen will get 3. Right? Now this is the chemical formula. But I want you to balance. That means whatever it is in the left hand side should be equal to the right hand side. This is what you have to do. Right?
Won't
Now,
aluminium be,
sorry.
Miss, won't oxygen be 6?
Wait. Let me balance it. First of all, I wrote the equation, then let's balance. Right? So, how many oxygens do you have here?
2.
You have 2. How many oxygens do you have here?
3.
Here comes the problem. Now, this was not something that you tried before. Now, at this situation, what do? You take a multiple. You multiply both the sides. At the end of the day, you have to get same value. What can you do for that? On this side, you multiply by 3. On this side, you multiply by 2. Then 3 by 2, it is 6. 3 by 2, it is 6. You get the same answer at the end. Do you get it?
Yes, teacher.
Then here you add 3 and here you add 2. Then look here, 3 into 2, 6. 2 into 3, 6. Are they balanced?
Yes.
They are balanced. Now come for aluminium. What is aluminium? How many aluminium atom do you have here?
4.
You have 4. How many aluminium do you have here?
1.
You have 1. So how do you make it as 4?
Multiply by 4.
You multiply by 4. Right? Then you add 4 in front. So this is the balance. People who attempt, I think Safia answer. Children, can you all make me the host? I don't know who is the host. Jacob, can you make me the host? Or else wait, okay. I'll try to become the host. Okay. Okay, thank you. I'm sorry, by mistake only the meeting got ended. Okay. All right. So let's continue. Right? So this is the balanced equation. This is the balanced equation. Did you all understand how to balance? Do you find comfortable to do this way? You should be.
Miss,
right?
I have a doubt.
Sorry?
Miss, I have a doubt.
Yes, teacher.
Yeah, what's your doubt, Amina?
Miss, when combining the valencies, won't it be 6? I mean, I got a different answer.
How can you get 6? Look
I
here, the
multiplied the
valence.
3 with
Uh,
2. And
come
I
again,
got
come again.
when combining the valence itself, I got 6.
How do you get it as 6? Now, the valency of aluminum, look here, the valency of aluminium is +3, right? The valency of oxygen is -2, right? Now, you erase the sign, you interchange. You are going to give the valency to the opposite one. You are not going to solve them. You are not going to do any multiplication or nothing, right? Then, aluminium will get 2. Okay, aluminium will get the valency of oxygen, right? Oxygen will get the valency of aluminium. This is the answer that you get. So after this, you're going to balance on both the sides. What did you do?
Miss, can't we multiply the 3 with that O2?
While balancing the equation,
Now it's
like
just
I
Miss.
mean
I
the
mean, like,
valency.
yeah, I mean that 2 next to the O2.
This one or this? No, 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 no. You're not going to deal with anything like this. You're not going to do that. Okay? You are going to consider just the elements valency. Right? You are going to consider the element valency. Now, if it is was H2O2, you're not going to multiply the valency by 2 and write it here. No, no, no. Not that work is done. Okay? You can't do that. What you have to do is you get the valency of the element. You don't see the count. You don't see the count over there. You just get the valency of the element. Then you cross multiply and you write it. Then only on both the side you balance them. Understood? I think that's the error that you have made.
Okay, Miss, thank you.
Okay. So you can't do that way. Now, if it is the case, here also that should happen. Because oxygen does not exist as a oxygen in nature. You always find it as O2. Right? So therefore, you don't multiply the valency by 2. Right? You don't do that. Okay. All right. Then let's do another one. Let's do another one if anyone wants. Right? So I think probably we will be doing the single displacement and the double displacement in the next class because we don't have time. Let me give you the example as let's go with potassium, oxygen gas. For now, children, I'm taking on the oxygen gas because it's like this. Water and everything, it is like you have to like separate them and do stuffs like that. That is not possible to teach within these few minutes. So let's do with water, oxygen itself. Now do this. I'll give you 1 minute. Now it is 8:53. Complete it by 8:54. 1 minute. Now you should be well practiced to do this. Trust my words, now you should be practiced. Do it. Everyone has to do. This is for your own good. When you are practiced, automatically your hand will go and do the work. You don't have to tell your hand to do this, do that. It will do the work. So you have to be fluent in that way. And children, make sure to send a feedback to my number regarding the class, how it was, the seminar. So if it is a good review, I will be happy. If there are any changes to be done, inshallah in the upcoming class, it will be done. Do it. Okay. Can we discuss? Can we discuss, children? Everyone attempt it. Children, if you don't attempt it and if you tell me I don't understand, that is a waste of time. You attempt it and you tell me I did not understand, there is a point. Without attempting, don't tell like I did not understand. There is That's not possible. No, when you attempt it only, you will undergo the answer. You will understand the answer, how to get the answer. Okay. Now look here, let's discuss. First of all, you have to take the valency. What is the valency of potassium?
+1.
The valency of potassium is +1. Right? Then what is the valency of oxygen?
-2.
-2.
Right? Then what do? You erase the sign. Then you interchange. Then potassium will get 2 and oxygen 1. You don't write 1. Okay.
Okay.
Now what are you going to do? You're going to balance. How do you balance? First you start here, right? When you're balancing, the left hand side should be equal to the right hand side, right? So how many oxygen do you have it in the left hand side?
2.
You have 2. How many oxygens do you have here?
1.
1.
1. Then how do you make them equal?
Multiply by 2.
You multiply by 2. Then where do you add 2? Can you add over here? Can you add like this? K2, 2O. Can you do that?
No.
You can't do that. Then what do?
We put it in front of the compound.
Very good. You put it in front of the compound. You add 2 here. Right? So when you add 2 there, you have 2 oxygen here, 2 oxygen here, balance. They are balanced. Then you take potassium. You take potassium. How many potassium do you have here?
4.
You have 4. How many potassium do you have here?
1.
1.
1. Then how do you make them equal?
Multiply by 4.
Multiply by 4. Then you add 4 in front. So this is going to be the balanced equation. Did you get this answer? By the time you should get the answer. If you have practiced from the beginning. Very good. Hannah has got the answer. Who else?
Yes, I got the
Hannah
answer.
has- Very good. Very good, Amina. Right. Who else? Hafsa. Very good, Hafsa. If you have got the answer, good job. I really appreciate your attempt. That's really good if you attempt the question. Zara, very good. She has got the answer. Zahra also has got the answer. Very good, very good. Keep it up. Right. So if you wait for just few minutes, I can teach you the single displacement and double displacement as well. Can you all wait? So it will be finished at one shot.
Yes, ma'am. Yes.
Right. So let's do that. Okay. Right. So after that, I'll give you the work which you have to do. Right. After that, I'll give you the entire work that you have to do. Right. Now we are going to talk about, now concentrate. Okay. Now concentrate. The balancing part is done. Now we are going to talk about single displacement reaction. Right. In single displacement reaction, children, what is going to happen is where one will switch their place. Okay. Now when you have magnesium and copper sulfate, you have magnesium and copper sulfate, right? You have magnesium. Let me write smaller so then I will have some space. You have magnesium and copper sulfate, right? Now look here, children. Look here very carefully. You have to understand how the work is done, right? You have to understand how the work is done. Listen. Now, what is the valency of magnesium?
+2.
The valency of magnesium is +2. Now, copper sulfate, right? So, first of all, let's go with a simple one. Wait, not copper sulfate. Let's take hydrochloric acid. That will be more simple, right? Copper sulfate is a bit complicated because you don't know the valency of copper. Okay, for now, let's go with hydrochloric acid. Now, hydrochloric acid is a compound. Hydrochloric acid is a compound. Now, when you have a compound, as I told you, compounds are made out of iron, right? Positive ion, negative ion. When you break this hydrochloric compound, it will release H plus ion and Cl minus. Okay, it is going to release H plus Cl minus. Now tell me, magnesium is plus 2. It will go with hydrogen plus or Cl minus? Positive will be attracted by the negative or a positive? Tell me, children.
Negative.
Negative.
Negative. Children, are you sleepy? Just spend some time. You will feel, I don't know if you are feeling sleepy. Okay? You have to sacrifice. Okay? Followers are getting near. Right? So magnesium will go with chlorine. Magnesium will go with chlorine. Now you are going to take magnesium over here, chlorine. Right? What is the valency of magnesium?
Plus 2.
Plus 2. What is the valency of chlorine?
-1.
Minus 1.
Minus 1. Okay? Then what do? You erase the sign and you interchange. Then what will you get? You will get magnesium to chlorine. This is what you will get. Then you write that. Magnesium to chlorine. Then you can see, children, hydrogen ion is present. Generally, when you take the atmosphere or earth, you don't find hydrogen atom. In nature, you don't find hydrogen atom. This hydrogen atom will combine with another hydrogen atom and they will form H2 gas. Okay? They exist as H2 gas. So therefore, this hydrogen ion will combine with another hydrogen atom and they will form H2 gas. This is called as a single displacement reaction. Now look here. Initially, when it is a reactant, when they are a reactant, magnesium was alone. Hydrogen and chlorine was together. After the reaction, hydrogen is removed and magnesium has taken the place. Hydrogen is removed, magnesium has taken the place. That you call it as single displacement reaction. One element is being displaced by another element. Magnesium, hydrogen is being displaced by magnesium. In the position of hydrogen earlier, magnesium is there. Here you see, hydrogen was with chlorine. After the reaction, you find magnesium with chlorine. So that you call it as single displacement reaction. Understood? Understood? Okay. So that you call it as single displacement reaction. Clear? Sure? Any doubt?
No, miss.
Okay. Then when you have the single displacement reaction, now children, they are going to be displaced. They are going to be displaced, right? So when they displace, children, they can displace the element above them in the reactivity series. Now let me write the reactivity series over here. Potassium, sodium, calcium, magnesium, aluminium, silicon. Sorry, not silicon. Zinc. I'm just telling the periodic table as a flow. Right? Zinc, iron, tin, lead, hydrogen, copper, hydrogen, mercury, copper, silver. Below that you don't need for now. Right? Now you see here, hydrogen is here. Right? Hydrogen and magnesium. Magnesium is displaced by hydrogen.
Miss,
Hydrogen was initially with chlorine. Right? Hydrogen was
mercury should get changed, right?
Sorry?
Miss, in the activity series, copper comes first, right? I mean, after hydrogen.
Sorry. I'm sorry, I by mistakenly wrote. Okay. Now look here, hydrogen is here. Magnesium is above. Magnesium is above hydrogen. You find magnesium over here. So when they are displacing, when an element is being displaced by another element, they can displace the element above them in the reactivity series. Now, hydrogen can't be displaced by copper. Why is that? Copper is below. You can't get copper Cl. Something like this. This is not the standard one. I'm just randomly telling you. Instead of magnesium, you can't take copper. Why is that? It is below hydrogen. You can get calcium with chlorine. You can displace hydrogen and calcium. You can displace hydrogen and aluminium. You can do that. Why is that? All those elements which I mentioned, like calcium, aluminium, are above in the reactivity series to the hydrogen. They are above in the reactivity series from hydrogen. So when you are displacing an element by another element, it should be above that. Now think and tell me, you have such a reaction like you have zinc plus copper sulfate. Right? You have zinc plus copper sulfate. Now this is a single displacement reaction. Right? Now what is going to happen? Look here. Zinc is 2 plus. Right? Zinc is 2 plus. Then copper will break down. Copper is 2. Right? Copper is 2. Right? Then sulfate, SO42 minus is 2. This is also plus 2. Now zinc will go with which one, children? Is it with copper or sulfate? Copper or sulfate?
Sulfate.
With sulfate. Okay. Then you will see here zinc and sulfate, and copper you will see here. Now can you see, children, initially before the reaction, zinc was alone. Right? Copper was with sulfate. Right? After the reaction, what is happening? Zinc, not zinc, the copper has taken the position of zinc, and zinc has taken the position of copper. Right? Now, copper's position is being displaced by zinc. Copper's position is being displaced by zinc. How did you see that? You have copper here. You have zinc above. Then, can they displace? If they are above? Yes or no? What do you think? Yes, they can displace. Why is that, children? You have the element here, which is already it was in combination. Right? Now you see that zinc has been displaced the copper's position. Here copper was with sulfate. After the reaction, zinc is with sulfate. How does that happen? How it is possible? Because copper is here, zinc is above. Then they have chance to displace. If it is gold, if it is silver, it is not possible. Why is that? Copper is here, silver is here. That is below. Therefore, they can't displace. Understood?
Yes, miss.
Right. Now, take out the tune. Now, let's stop from here. Like, do the questions and leave. Okay, don't leave now itself. Okay, in order to see whether you understood or not, please attempt the question. Right? Please attempt the question and leave. Right. Can you name all 4 types of displacement, all 4 types of chemical reaction, and write each example for first 3. Combination reaction, decomposition reaction, and single displacement, because double displacement we did not study. Do that part only. Do it, everyone has to do. Okay, children? This is for your own good. Trust my words. So did you all learn something? Did you improve from the session? Just let me know. Yes, that's great. A lot. That's nice to hear. We look forward for more free sessions. Do we do it? Everyone has to attempt, right? Once you all are done, let me know, children. We'll discuss once again and let's end up the class. And next week, we'll continue with double displacement. Children, please share your feedbacks of the session. So it would be a great help in WhatsApp. Don't send it in the Zoom because I will not be able to read it. Sometimes I might have missed it. So I just wanted to have some satisfaction for the work that I have done today. So if possible, do that. Do it. I want everyone to attend. Please just don't stay and just stare at the screen. Okay? My number? Okay. I write it on the board. So I write it here. This is my number. And related to science, if you have any doubts, you can contact me. I will help you out without any hesitation. Do all the works which I told you, children. This is for your own good. If you take a step, complete it. Don't just leave it at a point. Since it is hard or since you forget it, don't do that. Study tips. Now, contact me in WhatsApp. I'll help you out. I'll try to give a personal like a plan, because a general plan will not work for everyone, right? So therefore, a personalized plan will be more helpful because everyone don't work at the same time. Some people study in the morning hours, some study in the night, so it differs. So it's not going to be a common thing. So as for me, I would tell you studying in the morning hours is much better, like early morning. So there is a scientific research in the morning, like early morning. I don't mean at morning in the sense it is after 10 or 11, not that. I'm telling early morning, like around 5, 4. So when you wake up and do something, okay, when you study, you will be more productive in the day. You wake up early and see on a day. You sleep early, right? You don't like sleep at night, like around 2 or 3 and wake up at 1, not that. You sleep early with a moderate time and you wake up early in the morning. Okay? You will find your day much productive than the normal days. That is true. And when you study in the morning, your brain will function 100%. That is a scientific research. So I am a morning person. I used to study like around, I do remember yet when I was doing my O levels, like back then. I used to wake up at 2 a.m. and I used to study. So that was a great time. So I don't wake up late nights. Even now, I can't do that. I mean, I'll just send this feedback to to the WhatsApp of for my number, then it's easy. I got an A for science. Don't worry. Experienced one is talking. Okay. Even my studying method was like teaching. I used to study by teaching. You know to who? My tables and chairs at home. They were the first student. Teaching is the best way of study. Trust my words. That's really a good thing. Teach your friends, whoever is in need. Do that. As a help, as a charity, you can do that. So in return, you will get better. Okay, I think y'all are done. Can we discuss? Just I'll tell you the answer. For the sixth one, look here children. What are the 4 types of chemical reaction? What are the 4 types children? Tell me now. What are the 4 types of chemical reaction? Come on children, talk. Tell your answers.
Chemical decomposition, single displacement, double displacement.
Okay, where's the combination reaction? Did you tell?
Yeah.
Okay, I did not hear it, but okay. So example for each, let me write it on the board. If you are struggling to do that, I'll give you. Right? For the first one, which is a combination reaction. Combination reaction. That is, you can take sodium plus oxygen and they will form Na2O. Magnesium plus oxygen, you will get MO2, right? Balance this. Okay, I'm not giving the balanced one, you balanced it. Okay, then for decomposition, as I told you, right? Decomposition reaction, you can take calcium carbonate, where it will be formed into calcium oxide and carbon dioxide. Then hydrogen peroxide, you can take that, right? Hydrogen peroxide will break down into water and oxygen, right? Single displacement, balanced it. Okay, I'm not balancing it. Okay, single displacement is you can take magnesium and hydrochloric acid. They will form magnesium chloride and hydrogen gas. Then as another one, zinc plus copper sulfate. Then at the end, they will be forming zinc sulfate and copper. Right? If you all have written this, great. Right? Balance it. If you don't know, contact me in WhatsApp. I'll help you to balance. But I hope with the knowledge that I gave you today, you will be able to do that. Right. So children, are you all satisfied with the day? Did you all study something new? Are you improved by yourself? Tell me that. Yes. Yeah, that's great. Very good. Really happy to hear that. Okay. So that's all for the day. I hope it was very useful to you. Right. You will learn something new and we'll look forward for more upcoming free sessions. Probably, inshallah, in the upcoming days. Right. So then that's all for the day. Thank you so much for joining and I hope you gain the benefit out of the day. Thank you for joining and be there till the end. Barakallah. Y'all can leave. That's all. Assalamu alaikum.